Imagine a night like any other, a tapestry of stars overhead, each one a silent witness to the passage of time. The constellations we know so well serve as celestial landmarks, guiding sailors, inspiring poets, and igniting the curiosity of scientists. But what if, among these familiar patterns, one star dramatically changed its appearance? What if a distant sun, unremarkable until now, suddenly erupted in a cosmic cataclysm, a supernova near Earth, sending shockwaves across the universe and altering life on our planet forever? Tonight, we explore a hypothetical yet scientifically grounded scenario: Supernova Near Earth, the IK Pegasi Event. We delve into the potential impacts of a nearby supernova occurring within our lifetime, a cosmic event that challenges our understanding of the universe and our place within it. IK Pegasi, also catalogued as HR 8210, resides approximately 150 light-years away from Earth, in the constellation Pegasus. To the naked eye, it's just another point of light among countless others. But behind its modest exterior lies a complex and potentially volatile relationship, a relationship that could lead to a supernova near Earth. In our hypothetical scenario, this celestial duo reaches a critical point. The white dwarf, ever the silent collector, siphons material from its companion at an accelerating rate. As it accumulates more mass, the stage is set for one of the universe's most powerful and awe-inspiring phenomena, a type Ia supernova that could have significant effects on Earth. One clear night, astronomers noticed something unusual. IK Pegasi, typically a dim star requiring telescopes to observe in detail, has brightened significantly. Alerts are sent out, and soon, observatories worldwide turn their instruments toward Pegasus. Within hours, the entire planet becomes aware of the event. IK Pegasi is no longer a distant star. It has become a celestial beacon, visible even in cities plagued by light pollution. The supernova near Earth has captured the world's attention. As days turn into weeks, the star's luminosity rivals that of the moon. Nights are bathed in an eerie twilight, disrupting the natural rhythm of life on Earth. But this isn't the first time Earth has faced the repercussions of a cosmic event. Approximately 500 million years ago, during the late Cambrian and early Ordovician periods, our planet may have experienced an extinction-level event triggered by a similar phenomenon, a nearby supernova or gamma-ray burst. Scientists hypothesize that a massive influx of cosmic radiation bombarded Earth, stripping away the ozone layer and exposing life to harmful ultraviolet radiation. At that time, life was predominantly marine. The increased UV radiation would have decimated plankton and other microorganisms at the base of the food chain, leading to a cascading collapse of ecosystems. Evidence lies in the geological record. Sudden drops in biodiversity, isotopic anomalies, and signs of rapid environmental change. The echoes of that ancient catastrophe serve as a stark warning of the potential consequences of a supernova near Earth. To comprehend the gravity of the IK Pegasi event, we must delve into the life and death of stars and how a supernova near Earth could occur. In a binary system like IK Pegasi, the white dwarf can accrete matter from its companion. As it approaches the Chandrasekhar limit, approximately 1.4 solar masses, the pressure and temperature at its core reach critical levels. At this tipping point, carbon fusion ignites explosively throughout the white dwarf. The star detonates in a thermonuclear explosion, a type Ia supernova. This supernova near Earth releases an immense amount of energy, making it one of the brightest events in the universe. These supernovae are so luminous they can outshine entire galaxies for brief periods. They emit high-energy radiation that can have profound effects on nearby planets. The immediate impact on Earth is both mesmerizing and unsettling. The sudden brilliance of IK Pegasi transforms the night. No longer does darkness provide solace for sleep or the cover of nocturnal creatures. The supernova near Earth has turned night into day. Animals rely on the Earth's diurnal cycle to regulate behavior. Birds sing at midnight, insects swarm in confusion, and predators lose the cover of darkness. Humans, too, feel the effects. Sleep disorders become widespread as the extended daylight interferes with circadian rhythms. Energy usage patterns shift, affecting everything from electricity grids to personal habits. Yet, the most profound threats are not those we can see. The supernova near Earth releases a deluge of gamma rays and cosmic rays, forms of high-energy radiation that, despite the vast distance, have the potential to affect our planet. Earth's magnetic field and atmosphere provide significant protection against such radiation. However, the sheer magnitude of a nearby supernova tests these defenses. Gamma rays interact with atmospheric nitrogen and oxygen, leading to the production of nitrogen oxides. These compounds catalyze the breakdown of ozone molecules, thinning the ozone layer that shields us from the sun's ultraviolet radiation. Just as it may have happened 500 million years ago, the depletion of the ozone layer exposes all life to increased UV radiation, setting the stage for widespread ecological upheaval. With a diminished ozone layer, more UVB and UVC radiation reach the Earth's surface. These forms of ultraviolet light are harmful to DNA, increasing mutation rates in all forms of life. The supernova near Earth has far-reaching biological implications. Medical facilities begin to see a surge in skin cancers, cataracts, and immune system disorders. Public health advisories urge people to limit sun exposure and wear protective clothing. Plants, the foundation of terrestrial ecosystems, are particularly vulnerable. UV radiation inhibits photosynthesis, damages cellular structures, and impedes growth. In the oceans, phytoplankton, microscopic organisms crucial for carbon dioxide absorption and as a food source, decline significantly. This mirrors the catastrophic events of 500 million years ago, threatening a collapse of the marine food chain. Cosmic rays ionize the upper atmosphere, potentially altering cloud formation and precipitation patterns. Climate models predict shifts that lead to more extreme weather events, droughts in some regions, floods in others. Faced with a multifaceted global emergency caused by the supernova near Earth, world leaders convene to formulate a coordinated response. Policies are enacted to mitigate health risks, protect food supplies, and stabilize economies. Public health campaigns become ubiquitous. Schools, workplaces, and communities adapt by installing UV filtering windows, adjusting schedules to minimize sun exposure, and promoting awareness. Scientists accelerate research into UV-resistant crop varieties and alternative farming practices. However, progress is slow, and the specter of food shortages looms large. As the crisis deepens, a chilling question emerges. Could we be facing an extinction-level event similar to the one that occurred 500 million years ago? Some experts warn that the cumulative effects of increased radiation, ecological collapse, and societal unrest could push humanity toward the brink of extinction. The public is gripped by fear and uncertainty. Panic buying, civil unrest, and a surge in extremist ideologies reflect the growing sense of doom. Desperate times lead to desperate measures. Governments consider radical policies, including strict resource allocation and even population control, igniting fierce ethical debates. Societal tensions escalate. Protests are met with force, and democratic institutions strain under the pressure. The thin veneer of civilization begins to crack. Inequality deepens. The wealthy retreat to fortified enclaves with advanced protection, while the majority grapple with the harsh realities of a world in crisis. The cumulative environmental damage reaches a tipping point. Ecosystems collapse, biodiversity plummets, and the planet becomes increasingly inhospitable. Resource scarcity sparks conflicts at local and international levels. Wars erupt over access to clean water, arable land, and energy sources. The spirit of global unity gives way to self-preservation. International cooperation breaks down, hindering any collective efforts to address the crisis. The supernova near Earth has laid bare humanity's vulnerability and the fragility of our existence. We have always looked to the stars with wonder, but seldom have we considered the perils they might pose. As we grapple with the consequences of a cosmic event beyond our control, we are forced to confront uncomfortable truths about our place in the universe. Is this the inevitable outcome of our hubris, a species that reached for the stars but failed to safeguard its own world? Or is it a call to awaken, to fundamentally change our ways before it's too late? The IK Pegasi Event stands as a testament to the indifferent forces of the cosmos. As humanity teeters on the edge, the choices we make now will determine whether we succumb to the fate that befell life 500 million years ago, or whether we find a way to defy the odds. One thing is certain: the stars will continue their eternal dance, indifferent to our struggles. The question remains, will we find a way to survive in a universe that offers both wonder and peril?